Is example 10.18 from your textbook. So basically the question says that there's a particle that moves from rest along a straight line, and its time at a certain displacement is given by t, displacement x, velocity v. Acceleration of this particle is given by dv dt. Acceleration dv dt equals to 2 times negative sine 2t plus cos 2t. And then they said find the equation for velocity, equation for displacement, and then there's a second part of the question: how much does the particle travel from the first and the second time the acceleration is 0. So first we are going to solve finding the equation for velocity and then equation for displacement. Okay, so basically the question they already give us the differential equation for acceleration, which is this one, which is they give dv dt equals to dv dt equals to 2 negative sine 2t plus cos 2t. Okay, so what we want is we want v. So in order to get v is we have to solve the differential equation. So how to solve? We see we can separate the t from the v. So if we separate, we'll just put v on the left side and then t on the right side. So I should get negative sine 2t plus cos 2t dt. Next part is I just integrate both sides. So integrate left side is v, integrate right side is, so I have 2, and then integrate negative sine 2t, integrating negative sine should be cos, so this is cos 2t over 2 because got 2 here, and then integrating cos is sine, so plus sine 2t over 2, and then plus c. Since both got 2, so actually I can take out half from this equation and just actually I can cancel semua ni. So I get v equals to cos 2t plus sine 2t plus c. So I need to find, here I got c, so actually I need to find just v in terms of t, cannot got, tak boleh ada c ni. So how to get rid of the c? We need to sub in boundary condition. Boundary condition in this question will come from the sentence they said that this particle move from rest. Move from rest mean t is 0, x is 0, velocity is 0, acceleration is 0. So we'll use this boundary condition. When v is 0, therefore time is 0. So we sub v with 0, and then t we also sub with 0. Plus sine 2, 0 plus c. Okay, so cos 0 is 1, sine 0 is 0 plus c. Therefore, c is negative 1. So after we get our c, we sub back into our equation, this equation. Therefore, our v is cos 2t plus sine 2t minus 1. So that is equation for v. Okay, so we get the first, this one. We need the second one, which is equation for x. So how to get equation for x? So I sambung dekat bawah lah. So v, you actually already learned this from your physics. V is rate of change of displacement, and since what we want to find is we want to find displacement x, so v is also equals to rate of change of displacement dx dt equals to cos 2t plus sine 2t minus 1. Okay, you already learned this. Velocity is rate of change of displacement, acceleration is rate of change of velocity. Okay, so now we just need to do the same thing, solve this to get equation for x. So x on the left side, t on the right side, cos 2t plus sine 2t minus 1 dt. So now we integrate this. Left side is x equals to cos, integrate cos is sine. So this is sine 2t over 2. Integrate sine is negative cos. Yes, so this is cos 2t over 2 minus t plus c. Minus t come from here, negative 1. Negative 1 is negative t. And then we need to find dc. How? Sama juga. We will use this boundary condition, which is that it move from rest. So kalau dia move from rest, maksudnya t0, x also 0. So we sub in x with 0 and then t with 0. 2, 0 over 2 minus cos 2, 0 over 2 minus t 0 plus c. Sin 0 is 0, so this is 0 equals to 0 minus cos 0 is 1 minus half minus 0 plus c. Therefore, c is half. So, tambah sikit lagi, the last, we just now sub in back c into our equation. Therefore, equation for x is sin 2t over 2 minus cos 2t over 2 minus t plus half. So we done our first part. We got the equation for v, we got the equation for x.